All right, what up, everybody? Today we're looking at velocity time graphs and how we can go from a velocity time graph to a position versus time graph. So, a velocity time graph is a graph that shows you how fast something's going at any given time, and a position graph is a graph that shows you where something is. So, if you get information from the velocity graph, you can translate that over to the position graph. Okay, and today specifically, we're not using numbers, so we're just looking at the shape of these graphs and how you can go from the shape of one graph to the shape of another. Okay, so just a little bit about velocity graphs, what they mean. Velocity graphs have a line here that's a zero line. That means zero velocity. Obviously, something with zero velocity is stopped. Anything above that zero line is positive. Anything below is negative. Okay, so if your graph line is in the top half, then you have positive velocity. If it's in the bottom half, you have negative velocity. Okay, you can also say something about how fast or how slow an object is, because if the graph's line is near the middle, it's going slow. It's getting close to stopping. Okay, whether it's on top or on bottom, either way, it's going slow. But if it's away from the middle, either way above it or way below it, that means you have an object that's going fast. Okay, you can find acceleration from a velocity graph because acceleration is equal to the slope of a graph. And so, even without numbers, you can tell that a velocity graph line that's going up has a positive acceleration, and one that's going down has a negative acceleration. Okay, a velocity graph that's flat has no acceleration. Okay, likewise, position versus time graphs have their own rules. To find the velocity of a position versus time graph, you look at the slope of the line. A line that slopes up has positive velocity, a line that slopes down has negative velocity, and a line that's flat has zero velocity. Okay, and for acceleration, you can look at the curl of the line. So a line that curls upward has positive acceleration, and a line that curls downward means the object has negative acceleration. Okay, some people say that a smiley face is positive, a frowny face is negative. So if you can imagine that your position graph is part of a smiley face, then you have a positive acceleration. If you can imagine that's part of a negative face, negative frowny face, either the left or the right or both, then you have negative acceleration. So let's look at this example. Here's a velocity graph, and the line is down on the bottom, it's sloping upwards and getting closer to the zero line. So what does that mean? It means you have a negative velocity because the graph is in the bottom half. And if you translate that to a position graph, that means negative velocity means negative slope, which means it's moving down towards zero. Okay, this velocity graph slopes upward, and that means you have a positive acceleration. A positive acceleration in a position graph is a curl upwards, so it's going to curl up. It's going to be part of a smiley face. The velocity moves towards zero. Okay, you can see that this graph line, as you go from left to right, is getting closer to the middle line, which is zero. That means it's slowing down. So on the position graph, you expect it to start steep, because steep means fast, and end flat, because flat means slow. Okay, so this is what the position graph will look like. You see it's moving downward towards zero the whole time, but it is curling upwards. You can imagine it's like the right side of a smiley face. It does start steep and it ends flat. So this is the only way to draw all three of those in the same graph. So that's the position graph that goes along with this velocity graph. Okay, here's another velocity graph. This time it's sloping downward, but it's still negative, which means the position graph will have the line moving towards zero. It slopes downward, which is a negative acceleration. So this time, instead of curling upward, the position graph is going to curl downward. It's going to be part of a frowny face. This velocity moves away from zero. Okay, so from left to right, the line gets further from the middle line. And that means that the position graph is going to be, the object is speeding up. So the position graph is going to start flat for a slow speed, and it's going to end steep for a high speed. Okay, so there is what it's going to look like. You see it's flat at first, then it gets steeper and steeper, okay, and it curls downward. Okay, so those are some examples of how to go from a velocity graph to a position graph, and I'll see you all in the next video.